Okay. So and where is it? And that just becomes, so sigma, yeah, okay, and that just becomes expected value of x minus mu squared, it should be. Wait. Yep, that's right. Yeah, that's right. Okay. Perfect. So variance is that, all that. If you're wondering how you got this, if you remember, expectation of x is what? Sum of your x's multiplied by this, right? So if I said, just like any function, if I said replace x for x minus mu squared, replace this for this, then this gets replaced, your x gets replaced for x minus mu squared times probability of x. So that's why that is that. Hopefully that proves it for you guys. Anyways, standard deviation is just a square root. That's all you need to know. Again, S on your calculator will be used for sample. I don't think we're going to be doing samples. We'll definitely be doing population. Sigma is what we need. Okay, I'm just trying to think if I can do it another way with you guys. Just want to see something. If I do variance this way, EX squared oh, you guys haven't even taught that yet. That's fine. Okay, no problem. Variance can be written a few different ways. That's why. Just trying to say it a different way, but all good. Find the variance and standard deviation. Okay, to find variance, the formula again is this. Variance of x is equal to the sum of your x minus your average squared multiplied by the probability. So I need average. I need to find my mean first. To find my mean, I've got to use this, E of x, which equals to each score multiplied by the probability, right? So 1 times this, plus 2 times this, plus 3 times this, plus 4 times this, which equals to 2.46. You understand that? So once you've got your mu, or your expected value, now we're going to sub it into our variance, which is sum of your score minus your mean squared multiplied by the probability of that occurring. Ready? Here we go. Your score, 1, minus your mean squared multiplied by 0.16 plus your score minus your mean squared multiplied by that probability plus your score minus your mean squared times by probability plus score minus mean squared multiplied by probability. There's your variance square rooted. There's your standard deviation. Anybody have any questions? Well, they are going to do the simple formula. Thought so. And nobody? All good? The formula for variance is a little tedious since we subtract the mean from every value. There is a simpler formula, and yay, there it is, E of x squared minus mu. So you could do that, or you could do the expected value of x squared minus mu squared. That works really well as well. There's the proof, which you guys should not even care about. I don't know why that proof's even there. But anyways, so variance can be what we just did, or variance can also be written as this. E of x squared minus mu squared. Again, you still need to find mu, so you've got to do that your normal way, which is 1 times 0.16 plus 2 times this, 3 times this, 4 times this, and there it is. that becomes mu. And then your variance is e of x squared minus mu squared. Now, e of x squared, because remember, e of x is this, right? So let me write it up here. E of x is this. So summing your score multiplied by your probability. E of x squared is just summing your score squared times the probability. So all you're going to do for ex squared is go the first score squared times by 0.16. The second score squared times 0.32. Your next score squared, and I think you guys get the idea, minus your average. Okay? Sorry. And then square root it, standard deviation. Any questions? Again, it does say you can use a calculator. At the moment, I don't want you guys to use a calculator just yet. I can teach that to you in a minute. It's not a problem. I just need you to know the math. Yeah, I guess let's try this one. Question 2. We'll do A first. All right, I'm not going to say anything for a few minutes. See if you guys can do that. All I'm going to write for you here is the formulas. So E of x, which you'll need for your mean, is mu, which is the sum of your scores multiplied, what am I writing? Sum of your scores multiplied by P of x. Your variance of x is equal to E. Oh, there's a few ways, but I would like you guys to get used to the second way because it's more relevant for our Year 12 topics as well as university. E is more the second version. And then E of x squared is just the sum of x squared multiplied by the probability. So that one's not too difficult, and you would have already worked out mu. Standard deviation of x is just the square root of your variance. Variance is represented by sigma squared. Standard deviation is represented by mu. By sigma, and this one's by mu. All right, perfect. Go ahead, start doing that. And if you get an answer out, let me know. Anyone got an answer yet for mu? No, really. It's weird. You guys not doing it, or wait a little bit longer, I guess. Still nothing. Can you guys even hear me? Or are we on mute, or what's happening?
I got an answer, but I don't know if I did it right.
Okay, tell me your answer for mean, please.
1.038.
0.3. Anyone confirm that's also right? No? Quiet. Let's see. My answer is looking like 7.01. How did you get this? So what are you thinking?
I went 1 times 0.09 plus 4 times 0.18 and so on. And then I divided it by 4. I should have divided that by 5.
No.
Yeah.
No. There's no dividing. Your mean is already, like, it's already been divided. Like here, this probability has already been divided by how many there were. So your mean is just x, this score, multiplied by p of x, multiplied by this. That's it. And adding them all up. Does that make sense, Maria?
Yeah.
So just this times this, plus this times this. That's really it. That is mean. Like, you're following these formulas. You're not doing it the old way. The answer looks like I got. Someone can confirm in case I put something wrong.
Yeah, I got that as well.
Okay.
Yeah, I got that.
Yeah, I got that too.
Nice. Variance. And then variance looks like this. E of x squared. So that means summing your x squared multiplied by the probability. So 1 squared multiplied by the probability plus 4 squared multiplied by the probability plus 7 squared multiplied by the probability plus 9 squared multiplied by the probability, and last one, squared multiplied by the probability, minus mu squared, so minus 7.01 squared. That's variance, which is sigma squared. Does that make sense, guys? So again, 1 times 0.09 plus 4 squared times 0.18 plus 7 squared times 0.26 plus 9 squared times 0.32 plus 10 squared times 0.15 minus 7.01 squared becomes 7.4899, which means standard deviation is 2.74. Just confirm all that. Okay, can I move on? Or are you guys actually struggling with this? I don't know, you guys are very quiet. What's happening? Did I go too fast? Stefan, you find this okay?
Yeah, it's not bad, not bad.
So are you actually confused on something? Like,
No, it's kind of all straightforward.
okay. Let's try a different question then. And that's it. That's the end of the chapter. Wow. Okay. Maybe we'll do a good little revision next week on this topic. All right, you guys. What are we missing? We've got the scores. What do we also need?
The frequency?
Probably.
Yes, that one.
Yeah. 1, 2, 3, 4, 5. But how do I work out the probabilities? There's a word there that gives it out to you.
It's uniform.
It's uniform, which means the probability is even all the way across. It's the same. So 1 out of 5, 1 out of 5, 1 out of 5, 1 out of 5, and 1 out of 5. Find the mean. Okay. A, mu. Mu equals mu equals 1 times 1/5 plus 2 times 1/5 plus 3 times 1/5 plus 4 times 1/5 plus 5 times 1/5. Average is, or mean is 1/5 plus 2/5 plus 3/5 plus 4/5 plus 1. 5 on 5, yeah, 1, which is 3. So the mean is 3, which, I mean, I should have just said that, but anyways, if it's uniform, the mean is just going to be the middle, right? You guys probably already get that bit. If not, the average is going to be the middle, because that's what mean is here. It's the middle, which is confusing because you got used to median. And just to confuse you even more, average and mean are not the same. We use them interchangeably, but they're not actually the same. Mean has what we say as you get a little bit older, it's got weight, whereas average has no weighting. And what we mean by weight, if you think of, let's say, the stock market, you might have put, I don't know, you might have 10 stocks, and you put $1,000 in that, distribute it randomly, let's say. The idea is a stock might have weighted, like one stock, like let's say Woolworths, is weighed a lot heavier or a lot more because it's a bigger company than, let's call it, ABC company that does lawn mowing. So mean is rather complicated, but obviously at your age we've simplified it to average, and I believe weighting is going to be part of the extension 1 year 12 bit that we've got to get through eventually. So you'll need to know that, but just trying to say, just to confuse you a little bit more, average and mean are different as well. But anyways, this is the middle. The mean is your middle bit. You don't care about that, just do the math. B, standard deviation. We don't do standard deviation first, we'll do variance first. It's just a better way of approaching it. So your variance is 1 squared times 1/5 plus 2 squared times 1/5 plus 3 squared times 1/5 plus 4 squared times 1/5 plus 5 squared times 1/5 minus mu squared. minus 9. Plug it into your calculator, you'll get an answer. Square root that, square root your variance, and you'll get your standard deviation. So let's get an answer out. And I think you guys are pretty good. 4 over 5 plus 9 over 5 plus 16 over 5 plus 25 over 5, which is 5. Take away 9. Variance is 2. Standard deviation is root 2. Cool. Again, that variance even makes sense because you have deviated away maximum from the middle to unity and to unity for uniform, only for a uniform, discrete random variable. So to me, I'm saying that just makes sense. But anyways, all right. And let me stop this recording.